All right, so thank you everybody for who's in attendance right now. I am joined by Carlos Flores. He is a technical trainer at Napoleon who specializes in HVAC systems. He has a robust background as a residential journeyman. So with that, Carlos has been able to hone his skills as both a service technician and installer, specifically emphasizing his expertise in retrofitting HVAC equipment. So we're very happy to have Carlos here with us today. So Carlos, please take it away.
Hi, thank you. As you said, talking about retrofitting a furnace in central AC to a furnace and heat pump. A little bit about myself. My name is Carlos. I am currently a technical trainer with Wolfstone Technical. I have worked in HVAC as a journeyman in service and installation for the past 7 years and found myself quickly training new technicians and found a passion as a trainer. I am here to talk to you about retrofitting a system and why we are moving towards heat pumps and what is expected of you as an installer and things to look out for when retrofitting a system. Any questions can be asked in the comments and we can come around at the end of the presentation. So what is driving the change? There is still a demand for gas furnaces, but air conditioner sales have been dwindling as they are getting replaced by heat pumps. With the regulatory authorities across North America working with big utility providers, they are promoting air source heat pumps with incentives and rebates. So there is a big push for change. So what exactly does that mean? With the Energy Star being phased out, the R2000 standard is going to become the new rating to improve energy efficiency of new homes. The ultimate goal is to achieve net zero homes. A net zero rating is a home that can generate as much energy as it consumes. Using efficient ways to heat a home is like an air source heat pump, better insulation and windows and solar panels. You'll be using virtually no energy consumption within the hydro companies. There are already communities that are already being built with the net zero energy guidelines in London, Ontario, in case you want to research it some more. And as you can see, we did go through some changes back in 2023 between the SEER ratings and as it's now considered a SEER 2 rating. The SEER 2 rating represents a more realistic efficiency energy rating that can be achieved by a system. With the ultimate goal of reducing our carbon footprint, we're going to see improvements in the HVAC equipment in homes and in businesses and strategic plans to roll them out. And just a question to a couple people is like, have you guys been starting to see the changeover request and what's your experience with it so far? So I wanted to talk about reviewing a system and sizing it. So a system, to review the system interior, we're going to be looking at the furnace, the duct, and the coil. What type of furnace is being used? Oil, gas, electric. Is the upgrade necessary? If they're are they taking advantage of any of the reboot programs, and what are the conditions to qualify? You already want to utilize the equipment that's already there. So ensure the coil that is suitable for the furnace and the heat pump, as well as can the ductwork handle the CFM and the capacity of the unit. You're going to want to take a look over the breaker panel. Any work that's been done in a breaker panel should be done by a licensed electrician. What kind of breaker does the panel take? Is there enough space for another double pole breaker? Is it a 100 amp or 200 amp panel? Based on the electrical code, you will determine what gauge wire you're going to be running from the panel to a disconnect. You're also going to want a minimum of a 4-conductor thermostat wire from the indoor unit to the heat pump, and a minimum of a 6-conductor thermostat wire from the furnace to the thermostat if you're planning on running a one-stage heating and cooling. And speaking on thermostats, what kind of thermostats does the customer have? We want to ensure that the thermostat that the customer is using is able to run hybrid heating. There are thermostats that does several heating and cooling options. At face value, they are cheaper than most smart thermostats, but these thermostats will run your heat pump as a priority and has a timer that if it's unable to achieve the heat, it will kick in your secondary source of heat. This is not an energy efficient way to run a heat pump. A smart thermostat will consider all the equipment that is installed using information like an outdoor temperature sensor, humidity, and utility costs, and they can determine the most efficient way to heat your home. As an example, the thermostat might, as an example, if the outdoor temperature is negative 20 degrees Celsius, the thermostat might not even kick in the heat pump, as it may be cheaper to run your backup heat based on your utility costs. Lastly, do they have an air conditioner? Where is it located? Can you replace the refrigeration lines? There is an environmental factor that a lot of people do forget. We don't want to be placing a heat pump where the house is getting prevailing winds. This can cause issues with your heat pump. My recommendation is to replace the copper lines, but that's not always the case in some scenarios. If you do have to reuse the lines because the location of the furnace in the finished basement, make sure that that you take your time to properly flush and using the appropriate kit. Properly sizing a system requires knowledge in the home itself. You can't just look at a home and determine the size of the system based on how big the house is. This is where taking a course on duct sizing and heat loss and gain courses will become helpful and make you into a better HVAC technician. We want to ensure that we match up the right equipment for home because improper sizing will lead to callbacks. In an old home where the calculations may say that a 60,000 BTU furnace and a 3-ton heat pump is recommended, but the ductwork can only handle 40,000 BTU furnace and a 2-ton heat pump, a conversation with the homeowner must be had, explain that either they go with a smaller equipment or some rentals need to be done in order to increase the ductwork. Because ultimately the complaints will be high utility bills and insufficient heating. This will come back to you as a company who installed the equipment and will lead to profit loss. So let's get it right the first time. So with all that information, what are our next steps? We want to review the options with the customer and educate them as best as we can. To make sure that they can make an informed decision, explain the basic principles of a heat pump operation, how the system switchover happened. There has been a lot of misconceptions with customers just because they got a heat pump means that they're never going to use their secondary heat. Well, that's not true. Then once everything is set in order, order your equipment and set a date for the installation. So replacement overview. Let's discuss what's required, what you need to replace the equipment. Some common tools are your multimeter, your manifold, and your vacuum pump. Some of the things that you might need is a flush kit and a flaring tool. And these are very specific to the installation process. As a technician, you should know how to use your tools in order to calculate your subcooling and your superheats in order to charge the system properly. Some other common tools, you got your Allen keys and your electronic scale and your 5/16 adapter. A lot of heat pumps are made overseas, which is why they have the 5/16 valves and require an adapter in order to connect to our 1/4-inch gauges. So first and foremost, before taking anything apart, we do want to disconnect all the power source to avoid any injury to the electrician. If an existing AC equipment is present, you're going to want to recover the refrigerant. You should have your ozone depletion substance certification when handling these refrigerants. Once this is complete, disconnect your lines and your line set and remove your coil. If the line set has to be reused, use the appropriate flush kit. If you are replacing the line, insulate both lines. You're going to want to place the heat pump on a stand as the heat pump does go into defrost mode. We want the excess water to exit the unit and not freeze inside. Make sure that the following manufacturer specifications when it comes to the clearances. In a home that uses propane as a secondary heat, a lot of installers forget that you do need 10 feet from a propane regulator. Any electrical work should be done by a certified electrician, but you do want to review the breaker size, and if a new one is needed, change it out with the size that's recommended for the system. And according to the electrical code, the gauge of the wire will be based on the distance and the amps of the unit. There should be proper drainage for the inside coil and the outside coil, outside unit. Since the outside unit will have ice developing underneath the unit, we don't want to cause any hazards on any walkways. You're going to want to run your thermostat wiring, install and program your thermostat. Read the manufacturer's directions on some equipment, as you will need to run the reversing valve on cooling or the reversing valve on heating based on the specification. And then based on the size of the heat pump, you're going to want to adjust any dip switches to set up the proper CFM for the equipment that is installed. So for the system requirements and commissioning, let's discuss what's required from a replacement standpoint. Um, we don't want to forget to log all the data on service/commissioning sheets, so you have not only a baseline performance and comparison, but also a record of any work you have done in the event you need it for whatever reason. This will include how much refrigerant was charged in the system, static pressures, settings, and your delta T's. Communication with the customer is key. Discuss the operation of the equipment with the homeowner, what they expect, and how to operate the unit. You want to discuss the warranty and the importance of regular maintenance, and leave all relevant manuals on site. Provide a point of contact in case of any issues that may arise. The more information they have before you leave, the less likely they will call you. Fortunately, I kind of ran that a little quickly than I expected, but is there any questions or that I can help out with right now?
All right, yeah, yeah, you definitely went through a very quick on that one.
I
So
think a little bit of nerves kicked in a little bit. I'm not gonna lie, but
oh no, for sure, I understand that. But yeah,
mhm,
we do have some people in the chat, so please, if anyone has any questions, obviously this is your time to kind of obviously we can pick Carlos's brain a little bit with this one, right? Because we have some
mhm,
time as well. So I guess
yes.
maybe I could just also tee up some questions as well too for the chat. What's everyone's experience has been like? What has been the experience like with installing heat pumps? Exactly how knowledgeable are some of the people in the chat, and kind of how frequently are you working with this technology? Are
Mhm.
there any issues, any things that you guys? All right, perfect. We have one question I see here from Luis. What are the average maintenance costs for heat pumps?
So the average maintenance cost all depends on the your local HVAC company that's servicing them. They can average between 120 to $140 for the service call itself, and it is recommended to provide maintenance at least twice a year or at least once a year, because you're already running the heat pump yearly, so you want to get done before the cooling season and the heating season, because you do want to get that in the springtime. You do want to get that brush away from the outside coil, or make sure that no ice or frost is developing on the coil itself.
Perfect. And then Luis had another question as well too. He asked common components that fail the most within. I'm assuming heat pump systems or heat pumps. So I
Mhm.
guess can you answer that question?
Yeah, so a lot of issues we've been finding is because of installer failure, based on where they install it, how far they install it from the unit. You have to follow the manufacturer specs. So if you are installing it above the vertical or the horizontal limits, you do have to install your oil traps. But for the most part, the heat pumps right now are pretty solid. When we come down to it, I've come across a couple boards that usually go as well. It all depends on environmental factor as well.
All right, Luis. Oh, perfect. I'm loving the engagement from Luis. So thank you so much. He also
Thank you so much.
he asked as well too. So his question was: you also mentioned a backup for heat source, and is also he
Mhm.
also asked why for that.
So the reason for a backup heat source is our temperatures up here in Canada are a lot lower than they are in southern states. When you look at a graph on how efficient a heat pump can provide after a certain degree, like I believe it's like -15 degrees, you do lose the efficiency of the heat pump and it won't be able to keep up with the home. So if you install a 3-ton heat pump, which is, if I remember correctly, 20 36,000 BTUs, you do lose about 30% of that efficiency as it gets colder. Um, and so it won't be able to keep up with maintaining the heat in your home. So using electric or gas is required when you get into those colder temperatures. And it also comes down like how long is the heat pump is running, how much electricity you're using compared to like, how fast a gas furnace can heat up your home and how much gas it uses. So this is why a smart thermostat is very crucial in setting up these hybrid systems, because the thermostat itself has switching tables that will switch it for you. So you're using the least expensive utilities to heat up your home.
All right, we do have a bunch of questions, so this is really good. Thank you,
Oh,
chat,
this
so
is
much.
awesome.
So, yeah, so I'll just read them off. So the next one we have is from Dean. He asked, "What's a good temperature to switch over from secondary heat to heat pump, and vice versa? Which thermostat is the best for this application?"
I'm not going to go into specific in brand names of a thermostat because obviously I can be a little biased since I'm from a specific company.
For sure.
I and speaking with our thermostat does have switching tables. So when you do set it up, you do actually input the information of your utility company. So let's say this is how much you pay for electricity, this is how much you pay for your gas, and so forth. So it itself has the logic in the graph to determine when the set point is of when you should be using your backup heat, when it's going to save you money than running the heat pump for longer. And some thermostat you can set up the set point. A lot of people do say to set it the switch point from a -5 degrees standpoint, because that's when you start to lose a lot more efficiency. And there are some provinces that are putting in standards. So I believe BC is saying that at 5 degrees it should be switching over to your backup heat.
All right, we also have another question here from Nathan. I'll read it. He asks, "We're looking at using a heat pump for our server room. Any thoughts as to whether or not this would be a good option?"
Is it for a server room? So you're going to want to be cooling off the equipment because the server rooms get very hot. So it all depends on the application. A heat pump can be efficient depending on the unit itself. I believe there are specific units to servers rooms where the compressor is actually in the room itself, and only the coil and the fan is on the roof or on the outside. That's not something that we usually deal with, as we're more a residential company. But I believe there are specific equipment for those server rooms.
Okay, and then we also had a question here from True North Energy. They mostly said, "How is a heat pump sized?" So I guess you kind of alluded to that a little bit in your presentation, but if you kind of wanted to go through that again. So
You'll go through it. Yeah,
yeah.
no problem. So when you're sizing a heat pump, a lot of I would say salespeople usually just take a look at a home and be like, yeah, you have this much square footage in your home. I believe a 2.5 ton would work, but that's not the case at the moment. And this is where I say that it's very good to take a duct sizing course as well as your heat and loss gain, because sizing a brand new build and sizing a home that's from the 1950s, even though they're the same square footage, you are going to be getting a lot less heat loss in a new home than you would be in an older home. There's a lot more draft, and so you do lose a lot more heat or cooling. So sizing an older home with a bigger unit makes more sense than a new home that may have a smaller unit. In the case of, I would say in the case of my house, even though it's a new build, I do have a lot of windows, so I do have to take into account that the sun actually hits our house a lot harder and heats up the home a lot faster. So putting a bigger unit in my home makes more sense. So taking these courses obviously will add to your knowledge and how to actually calculate your how much heat and how much gain and loss that you get.
All right. Then we also have a question from Robert. If the existing ductwork is too small for a larger heat pump, is there a benefit to installing a smaller heat pump to match the duct?
You can install a smaller heat pump to the duct. The only issue that comes across that is usually when you get the smaller ductwork is usually in an older home, so they will lose that heat through the house because not enough insulation. The windows might be not have the greatest efficiency, and so you do have to explain to the customer, yeah, we can install this, but it might not be efficient and it might not keep up with the home, or it might be running longer, so your utility bills will get higher because the ductwork is so small. So this is why having that conversation with the customer is very important to inform them that yes, we can do it, but these are the benefits and these are the downsides of doing this certain situations.
Okay, perfect. And then we also have a question from Phil. What parameters are most commonly used for changeover to backup, ignoring electricity pricing?
Sorry, can you repeat that?
Yeah. So, what parameters are most commonly used for changeover to backup, ignoring electricity pricing?
You so I would say at the depending on the thermostat you're using, because there are some thermostat that are able to run the heat pump synchronous to your secondary heat, especially if you're using something like a hydronics air handler. At that point, you can set it up that it runs simultaneously between 5 degrees and -5 degrees. But anything beyond that, usually you want to kick in your secondary heat because depending on the efficiency of the heat pump itself, um, you're not going to get that heat that people are used to, right? A lot of people switching from, let's say, oil to a heat pump and they get a gas furnace. One of the major concerns is that they're used to such a high heat coming from the vents and it heating up within minutes that the heat pump itself is actually just maintaining it. And so they're not getting that same kind of heat coming from the vents. So usually around the 0 to -5, depending on the efficiency of the heat pump, is when you want it to start switching over.
All right. And then we also had a question here from Frank. He asked, is Napoleon designing their own heat pump instead of Degree?
At the moment, no. It's still the degree units and degree air handlers.
Okay.
Yeah,
And then,
we are working on making a hybrid system with we've acquired a hydronics air handler, and so we are in the works of putting a whole package together with that instead of using a gas furnace.
and Nathan also had a comment. He said, I guess with that question, how would it do in the middle of winter for cooling? Which I'm assuming he's relating to the heat pump, the performance in the winter and the colder climate months. So I guess if you kind of
Mhm.
want to maybe touch on that as well, too.
Yeah, so there's not a very lot of situations where you're other than a server room that you're going to be wanting colder air with a heat pump, but it does work. And in the manual, it does state that it'll work in I want to say in negative 25 degrees Celsius. Might be I would have to double check that myself. But you can get the cool air in the colder weathers as well.
All right, then let me go through as well. We've had some people having comments back and forth, which we love to see.
Mhm.
Luis also had another question. He said, lately in Alberta, we have some cold weeks during winter, about -40 degrees. How efficient would an air source heat pump be?
That's where you lose a lot of your efficiency. We do say that the heat pump does work till -30 degrees, where it's able to extract heat from the air at -30 degrees. But that's why your secondary heat comes in, are because Canada gets a lot colder. You do need your gas, your electric, or whatever your secondary source of heat is.
Perfect. Okay. We just had another Malcolm had a comment that he was chatting with somebody. I could read it as well too. He said in BC, TECA, so Teca Forest Air Guidelines, is a good course to certify for duct sizing and equipment selection. So yeah, that's
Mhm.
more of a comment that he was having. All right, we had a comment from Farid. He said, if the existing duct is not enough to install a central heat pump, would it be advisable to install multi-head ductless heat pumps?
Yes, definitely. If that works with this situation, you can install it has to be a low ambient ductless system if this is going to be their source of heat. This is what they do use in New Brunswick. They don't have any air source um, heating equipment. Everything is ductless over there. So it is possible it will work in the colder weathers. So I definitely, if the heat pump and the ductwork does not work out, because there's also instances of where older home may only have electrical heating or radiant heating, right? So they don't have no ductwork itself. So, but they want to get away from that as well. So this is where we do recommend a multi-zone, low ambient ductless split unit.
All right, and then let's see. Malcolm just had another comment. Okay, so right now we have gone through all the questions, and I kind of been monitoring as well through
Hmm.
the comments. So, oh, we have another one from Frank. Is it possible to run a gas furnace and heat pump together like an electric furnace? If not, why?
Um, so the recommendation is no, that we don't want to run the gas furnace and the heat pump together, and it all comes down to gas code. So and the location of the coil. So when you install a coil on top of a furnace, the heat from the furnace itself won't allow the evaporation of your refrigeration to properly in the coil itself because of the heat it's receiving from the furnace to the coil. And you don't want the coil before the furnace because the moisture that the coil does let off in the summertime, you don't want that affecting your furnace or rusting on any of the parts there. So according to the gas code, you cannot put the coil in before the furnace, and it won't. When you put it after the furnace, the heat from the furnace won't react with the refrigeration well, which is why electric heat and hydronics air handler is the way to go when you're doing simultaneous heating because you're able to put the coil before the system itself, and so whatever heat that the coil is letting off, the hydronics or the electric heating is just compensating for the extra heat that you require. I hope that answers the question.
So yeah, if anyone else has any other questions, like I said, we still have some
Mhm,
time. And if we don't have any other questions, then we can obviously, oh, it is worth noting as well
mhm.
that these presentations will also be turned into feature articles that will be featured in our magazine, both digitally and print. And also, this presentation will also go up on our Training Trades website and on YouTube later on. So you
Mhm.
will have follow up. And so if you have any other questions as well, too, or even just want to have another follow up, this presentation will be kind of in a written form as well, too. Um, yeah, if everyone has some more questions, definitely I think Carlos would love to field some more questions
Oh,
if
for
anyone
sure.
has some. And I
Yeah.
guess while we wait for some questions, if people want to jump in through, I guess I could ask you, Carlos. Obviously, you've been in the industry
Mhm.
for a minute now. What have been kind of the trends lately that you've been seeing, or what's been kind of like, what have been the biggest trends or kind of the biggest innovations that you've seen kind of within the heat pump space?
What he does. So, before I worked with Napoleon, I worked for a company that does supply fuel, so oil and propane. And with the costs of propane and oil, we did get a lot of installations to heat pumps or to ductless systems. And this is why a lot of the misconceptions comes in because the way it was propagated that a heat pump does work to negative 30 degrees, but it doesn't mean that it works efficiently. So a lot of the trends I was seeing is that people on oil or on propane would get heat pumps in the assumptions that, in case the heat pump doesn't work, we have our backup heat. But that's not the case. It still runs to either help defrost the coil and it still runs to help with the switchover when the heat pump can't provide enough heat to sustain your home. And so that's been a lot of the service calls that I've seen in that kind of trend. Um, And then obviously a lot of customers are wanting to take advantage of the program itself, even though they've had an air conditioner that's not even 4 or 5 years old. They just want to take advantage, and they're ready to switch over to a heat pump and get rid of the air conditioner because they want to save the cost on the fuel as well as take advantage of the rebates since it was covering most of the installation anyways. Um, And so yeah, so that's been and oil is a dying trade. Like we've been ripping out a lot of oil furnace. You do get the old lad that is a diehard fan of oil because of the heat that it does produce, but it's not efficient at all, right? You lose like 20% of your heat just going through up the chimney, right? Or even more than that. Um, and when it comes to sizing up these older homes that do have oil furnaces, luckily with the oil furnace they do have the bigger ductwork, but their house is not up to standard, so the insulation isn't there. You can actually feel the draft wind coming through the home as the heat comes in. The heat escapes, right? Because with the amount of heat that oil used to produce, it would be able to stay in it. But with a heat pump, it's meant to try to sustain the heat at a more comfortable level, and with it just dissipating like that, it works a lot harder. Which is why some of the rebates do require you to upgrade your insulation, to upgrade your windows, and they do a draft. They come and do a draft test themselves. So yeah, I have been seeing a lot of the changes, and and as well as even in London, like I was saying before, they are working on a net zero home. So I believe it's called. There's a community. I don't remember what it's called, but they're actually already built the homes and they've had great success where the energy that they get from the solar panels is enough to power their home and heat up the home without actually having any uh, hydro bills.
Okay, we also had a question from Frank. He
Mhm.
said, any idea why the building code still doesn't recognize heat pumps as a primary source?
It comes down to the efficiency of it. If you run a fossil fuel in your home, you're going to get the heat no matter what the conditions are outside, because the heat pump is so reliant on efficiency and how cold it is outside, and it might not provide heat. It could happen that your home gets too cold, and now you're running into issues with frozen pipes and issues with the insurance. So they always want to back up heat because we do hit a weather where it's negative 40 degrees, that heat pump isn't going to work, right? You're not going to get the heat out of the air. So that's the reason why the heat pump isn't considered a primary source. You still need a backup heat, and you are going to need a backup heat regardless of how far we go with the heat pump, because the way the heat pump works is it's a transfer of heat. We pull the heat out of the air and we bring it inside. At a certain time, if there is no heat, there's not enough heat to be brought inside, then uh, what are you going to do about it, right?
All right, let's see. Okay, Phil also had a question as well too. I've used the Arcan heat pump sizing tool. It's not intuitive for balancing point calculations. What are others using? So that's more of a comment, but also, do you have any suggestions as well for Phil that he could use?
Um, I'm just trying to think here.
Mhm.
Or, unfortunately, I don't deal with so much with the calculations myself. Usually, we do rely on the sales team to take care of that situation. And even when we do set the balance point on a thermostat, our thermostat itself does it all manually, right? We just input the information that it requires, and it itself has the logic to do it itself. So we don't actually have to set up the balance point.
For sure. And Luis also had another question. He said, are water source heat pumps less costly in the long run?
Um, I would say yes, because when you're using a hydronic system with a heat pump, is it, so let me repeat that. Are you talking about the water source heat pump in the sense that geothermal, or are you talking about like a hydronics and a heat pump together?
I guess I'll wait for Luis to follow up with that as well
Yeah.
too.
But with the hydronic system, you're heating up a coil within the system itself and maintaining that heat through a boiler. It doesn't use as much gas as a furnace, so that's what the reason why we're creating a hybrid system using the hydronic system. I'm using, and so yeah, it's very beneficial to use a hydronic system instead of a furnace. Hydronic, yeah, okay. So yeah, you're heating up a coil using like I would say like a Navian boiler. It could be a combi boiler. It could be just a standard boiler. Um, a hydronic system uh, will maintain the temperature of the heat of the coil as well as it can supplement the heat pump, so that way it can run simultaneously, not so use so much fossil fuel. Um, the nice thing about the hydronics is you can also zone them depending on the system you have itself. So you can actually just provide heat to sections of the house depending on your situation as well.
All right, Frank also had a question. He asked, this is specifically with a Napoleon question. He said, has the bugs been taken care on the Napoleon thermostat?
I'm going to say yes. I know the team has been working really hard on the thermostat. There's always constant new versions coming out, fixing all those issues. So at the moment, as I use one myself, I haven't had any issues. There are going to be future updates so we can run our hydronics and heat pump simultaneously instead of separately, so we don't have to set that balance point. But yeah, no, for the most part, the team has been working really hard on fixing those issues.
All right, perfect. All right.
hmm And the thermostat itself, it is an in-house design, so it's always been a work of progress, making it our own Canada-made programming, right? So as people use and abuse it, there's always it'll be a little bit issues coming up, and we're going to be right there to fix it.
Perfect. Well, guys, I really appreciate you guys joining in with the conversation as well too and asking
hmm
these questions. They've been
Oh,
really
I love these
helpful.
questions, honestly.
Exactly. This is the whole point that of these
Yeah.
webinars that we want to do as well too. Is obviously we will have people like Carlos, the technical experts, who provide these information, these presentations. But we also want to hear from you guys as well too, if you have thoughts, questions. So
hmm
this has been really great. Um, Malcolm also had a comment saying total heat loss for the specific building is also a consideration in that calculation, which
Yes.
I'm assuming he's relating back to his the comment he had before where he mentioned that he's the calculation kind of that he runs, which was in
hmm
response to Phil's question that was earlier as well too about the all right, guys. Well, if you don't have any more questions, I'll kind of keep it open again for another minute or two. Of course, as well, obviously, don't want it. Well, shameless plug as well with Plumbing HVAC magazine. We do have articles on there specifically regarding to obviously heat pump technology as well too. In our last edition for this September issue, we had one specifically on retrofitting and retrosizing air source heat pumps in the residential homes. So you want to take a look at that as well too. And then, of course, Carlos, do you have a slide that has your email potentially or any other contact information that people can maybe use to kind of get a hold of you if they have any follow-up questions as well too?
I'm going to write that down in the chat right now.
Perfect. Okay.
So let me just confirm that itself. Okay, there you go.
All
So
right.
yeah,
Perfect.
you guys can email me if you have any questions, even if it's Napoleon specific. Even if I don't have the answer right away, I can always get it to you. I do have access to the entire team, so by all means.
All right. Luis coming in hot again with another question. I love it. He goes, so here in Canada for residential applications, the air source heat needs a backup. And with wanting to get away from fossil fuels, electric heat is one of these options, or are there others?
So it's electric heat or hydronics. So I know they want to get away from fossil fuel, but you still need hot water in a sense. I'm not too sure how they're going to get away with the hot water without using a natural gas or propane in that sense. But if it's all electric, that's the reason why we do have an electronic air handler, and we size up the electric with the size of the house. But yeah, you're right. There, other than electric heat, there's no other backup heat that won't use fossil fuel at the moment.
And also, Luis, I think actually our next time slot, so the 205 to 305 sessions, one of them is going to be hosted from by Tom Heckbart from Ream,
Hmm.
and his session is actually going to be focusing on why heat pump systems in Canada will always have a backup heating system. So that
Hmm.
directly relates to your question. So he also might have a little bit more information, and that might
Hmm.
be one that's worth kind of sitting in on and kind of attending for you as well too. So kind of keep an eye out for that one.
Hmm. Yeah. All right.
All right, perfect. Well, guys, I really appreciate all the the
No
participation from you
questions.
guys. I really appreciate that.
Hmm.
Again, thank you, Carlos, so much for your presentation as well. I really
No
appreciate
problem.
taking the
Again, I
time.
apologize. I think the nerves got to me, and I kind of ran that a little quicker than I thought I would.
Honestly, I no, that's completely fine because obviously it's like
Hmm.
anything. Presenting like this, it kind of
Hmm.
the nerves get running. But no, I think you did fine, and the biggest part as well too has been the interaction with the chat as well too, and people
Hmm.
participating. So honestly, that's the best that we could ask for as well.
Yeah.
All right, last question because I saw Frank have one, so we'll shoot this one in here because we do have time for that last one. He
Yes.
said if a home has 100 AMP service, can on-still electric heat. So
Again,
this,
it all depends on what is in the home, right? If you want to run an electric heat, it does require um, uh, I believe it's depending on the size of the actual coil, 30 to 60 amps. Um, if you have a lot of plugs, I've known people to have they want an electric heat and they have a pool heater attached to their panel. At that point, we do recommend to upgrade it to a 200 amp panel just to justify that. It is safer to have a 200 amp panel when you are running electric heat, but again, that's all based on the electrical code and what they're actually running in the house.
perfect. And yeah, I just saw Malcolm's comment as well too. Yeah, so we definitely have more. These are all technical training sessions that we have.
Hmm.
It all depends on specifically the topic that is there. But our next sessions that we have as well too, please feel free to jump into there. And obviously keep asking questions as well too. If you have
Hmm.
specific technical questions, these are the people that you want to ask those questions on. So just looking at our additional topics, like I said, we have why backup systems will be prevalent in heat pump applications. We have the benefit of using VRF systems in commercial and residential applications. Michael Riddler will also be doing one specific geothermal application presentation, so that one also could be a little bit more technical as well too. But yeah, feel free to keep attending these sessions and ask your questions as well too.
Hmm.
All right, well then again, I think we're going to officially sign off as well too because we've
Okay.
had a lot of great conversation. But
Did you?
thank you again, Carlos. And guys,
No
if you
problem.
still have time, and I believe Kashif's presentation is still going on as well too. So if you want to jump over to that one as well too and kind of listen in on the tail end of that, please feel free to do that. And then again at 2:05, our next time slot of sessions will be starting as well too. So hopefully we'll see you guys there.
All right. Thank you. Bye.